Hi everyone, in this video I'm going to talk about again common source amplifier, but I want to investigate what will happen if we have our source resistance at source side. Source is not grounded. When source is not grounded, in this analysis actually nothing has changed. The change is in the gain. So we will investigate AC analysis of this circuit. So in AC analysis, let's draw the circuits. This is V inputs, here R source, and R1 will be parallel to R2 because this VCC will be grounded in AC case. This capacitor will be short circuited. This goes here ground, this goes here ground, and this current is 0. So this is V gate, and then here there is R source. Here this is source side. This current is GM-VGS. RD drain, and this voltage is VGS. So let's investigate the gain. Input resistance actually does not change. Input resistance here, if you look at from here, it is equals R1 parallel R2. Why? Because there will be no current passing through this side. So here, if you look into the gate of the MOSFET, you'll see infinity. So okay, let's investigate the gain. Remember, what was gain? V output over V input. So okay, and it is equals to V output over V gate and V gate over V inputs. So this part is easy. V gate over V input, just a voltage divider. R1 parallel R2 divided by R source plus R1 parallel R2. The important part here and change happens in V output over V gate. Let's write V output resistance. V output equals here, this is V output, equals minus GM VGS times RD. So what is V input? So here V input, no, we investigate V output over V gate. So we need to find V gate. V gate equals VGS plus GM VGS times R source. I just write here, this current comes in to the source side. GM VGS times R source gives me V source, and I added the VGS difference here, and I have come to the V gate voltage. So I will now take parenthesis V output over V gate equals minus GM VGS RD, and here I will take VGS parenthesis. It is 1 plus GM RS. So VGS will be cancelled. V output over VGS becomes minus GM RD over 1 plus GM RS. Remember, without the source resistance, V output over V gate was minus GM RD. So my gain reduced by a factor 1 plus, by a factor 1 over 1 plus GM RS. My gain reduced. So how can I avoid this? It is simple, guys. To avoid this, you can make this. Here's my V input. Okay, this source resistance generally for DC biasing. So it is necessary. So if you here, the key thing is adding here a capacitor. Think now, what will happen if you add here a capacitor? In DC case, there will be no current passing through this side. So in DC case, circuit becomes the same with the first circuit I have redrawn. With this I mean. So, but in AC case, this is important. In AC case, this time this capacitor will be short circuited and this resistance will between to ground, and there will be no current passing through this side. So we call this capacitor bypass capacitor. Why? Because it bypasses our source resistance. Bypass capacitor. So my gain, I can increase my gain by 1 plus GMRS factor simply by just adding these bypass capacitors. So what is gain now? V output over V gate is minus GM times RD. This capacitor is important. Sorry, there is a capacitor here. This capacitor is important and it is widely used. That's all, guys. See you at the next video. Take care of yourself. Have a nice day.